Donut Lab just dropped their independent test results from Finland's VTT Technical Research Center, and if you've been scrolling the headlines, you've probably seen people saying it proves their miracle battery works. I actually read the full report, every page. And here's the thing nobody is pointing out. This test only checks one of their 5 crazy claims. It doesn't show the battery's weight, so energy density? No idea. It doesn't test cycle life. It doesn't prove performance at extreme temperatures. And in one of the tests, the battery got so hot they had to stop 90 degrees Celsius. That's not a breakthrough. That's a single data point. This report, it confirms almost nothing. And today, I'm going to break down exactly what it does and what it doesn't. Section 1. What the report actually says. Alright, let's slow this down and actually look at what the VTT report really tested, because this is where things start to get interesting. First, the testing itself was conducted by VTT Technical Research Center of Finland, which is a legitimate, government-backed research institute. So this isn't a random lab or some marketing stunt. It's a credible institution using proper testing equipment. But here's the first thing you need to understand. They didn't test a battery pack. They didn't test a motorcycle battery. They didn't test an EV battery system. They tested one single battery cell. Specifically, a 26 amp-hour Donut Lab cell connected to a professional battery testing machine called a PECACT0550 battery tester. The entire experiment took place inside a climate-controlled chamber, which basically means the temperature and environment were carefully controlled so outside conditions wouldn't affect the results. Now the researchers ran 2 charging tests. The first one was at 5 degrees Celsius, which equals roughly 130 amps of charging current. If you're not familiar with C rates, think of it as how aggressively you're pushing energy into the battery. Most EV batteries today charge somewhere around 2C to 4C under ideal fast charging conditions. So 5C is already pushing the limits a bit. At that rate, the results were actually pretty strong. The battery reached 80% charge in about 9.5 minutes, and it hit 100% charge in roughly 12 minutes. When they discharged the battery afterward, it retained essentially all of the stored energy, meaning the charging process didn't waste much power. That's genuinely good performance, but then they pushed it much harder. The second test was done at 11 degrees Celsius, which translates to roughly 286 amps of charging current, and that's extremely aggressive. We're talking about a charging rate far beyond what most production EV batteries handle today. At that speed, the cell reached 80% charge in just 4.5 minutes. A full charge took around 7 minutes. Even more interesting, when the battery discharged afterward, the energy retention stayed between 98.4% and 99.6%, which is actually very efficient. So let's be fair here. Those charging numbers are real, they were independently measured, and at the single cell level, they are honestly pretty impressive. But here's the part that almost nobody talking about this report is mentioning. Because while the test confirms one specific claim about the battery, there are several much bigger claims that the report doesn't test at all. And once you start looking at what's missing, the picture becomes a lot less clear. Section 2. What the report doesn't say. Now here's where things start to fall apart. Because while the VTT report does confirm fast charging, there are some very big things it doesn't confirm at all. And the first missing piece is a big one: weight and dimensions. The report never tells us how much the battery cell actually weighs, or how large it is. And that might sound like a small detail, but in battery science, it's absolutely critical. Without the weight of the cell, you cannot calculate energy density, measured in watt-hours per kilogram. Why does that matter? Because Donut Lab's biggest headline claim is 400 watt-hours per kilogram. That would put it well ahead of most batteries on the market today. It's arguably the single most important number behind the whole miracle battery narrative. But here's the problem. If the report doesn't list the weight, you literally cannot verify that claim. We're talking about something that would take maybe 5 seconds to measure on a scale, and yet it's completely absent from the document. That's the first gap. The second one is cycle life testing. Donut Lab claims this battery can survive 100,000 charging cycles. To put that in perspective, most EV batteries today last somewhere between 1,000 and 3,000 cycles before significant degradation. 100,000 cycles would be absolutely revolutionary. But the VTT report doesn't test that at all. It only shows a handful of charge and discharge cycles. There's no long-term degradation data, no extended cycling, nothing that would come close to validating a claim that big. Then there's temperature performance. Donut Lab says this battery works from minus 30 degrees Celsius all the way to 100 degrees Celsius with minimal capacity loss. None of that is tested here either. And finally, cost. The company has suggested this battery could come in at under $130 per kilowatt hour, which would make it extremely competitive with current lithium-ion batteries. But a lab charging test can't verify manufacturing cost. So when you step back and look at the full picture, something becomes pretty obvious. Out of 5 major headline claims, fast charging, energy density, cycle life, temperature range, and cost, the VTT report verifies exactly one. Just one. Yet a lot of headlines ran with Donut Lab battery confirmed. That's not really what happened here. Section 3. The thermal problem. Now let's talk about the detail that a lot of people seem to be glossing over: heat. Because when batteries charge this fast, heat becomes one of the biggest engineering challenges. And the VTT test actually shows that very clearly if you read the numbers closely. At the 5C charge rate, things looked pretty good. The battery charged quickly and temperatures stayed within a manageable range using passive cooling. That's the simple approach where heat is absorbed by materials around the battery rather than being actively pumped away by cooling systems. So far, so good. But the real headline number, the one everyone's excited about, is the 11C charging test. That's the one where the battery hit 80% in 4.5 minutes. And this is where the thermal story changes. During that 11C test, the battery wasn't just sitting there by itself. It was connected to 2 aluminum heat sinks designed to absorb and spread out the heat. Even with that setup, the surface temperature climbed from about 26 degrees Celsius to roughly 63 degrees Celsius. That's already pretty hot. But the more revealing test happened when they reduced the cooling. When the battery was tested with only a single heatsink, the temperature didn't just climb, it spiked all the way to 90 degrees Celsius. At that point, the system triggered a safety cutoff and the test had to be stopped so the battery could cool down. Let that sink in for a second. That's one single cell, sitting in a controlled lab environment, with dedicated cooling hardware attached. Now imagine scaling that up to a real electric vehicle battery pack. Instead of one cell, you'd have hundreds or even thousands of cells packed tightly together. When batteries sit that close, they don't just heat themselves, they heat each other. Thermal buildup multiplies quickly. And this is where the marketing claim starts to look questionable. Donut Lab has repeatedly said this battery doesn't need active cooling. But based on the test results, even a single cell needed large aluminum heat sinks to keep temperatures under control at high charge speeds. Some industry observers have even estimated that if you tried to rely purely on passive cooling in a full EV pack, you'd need massive amounts of thermal material, potentially thousands of pounds of heat sinks, just to keep temperatures stable. That's obviously not practical for a vehicle. So when you hear the claim that this battery can charge in 5 minutes with no active cooling, it's worth asking a pretty simple question. If the lab test already needed big aluminum blocks to manage the heat, and still had to abort one run at 90 degrees Celsius, in what world is that no active cooling? Section 4. The voltage curve question. Now here's where things start to get really interesting, and a little uncomfortable for the people promoting this so-called breakthrough battery. Because when engineers and battery analysts took a closer look at the charging data from the VTT test, they noticed something that didn't quite line up with the hype. Specifically, they examined the voltage curve of the battery during charging and discharging. For those unfamiliar, the voltage curve is basically the fingerprint of a battery's chemistry. Different battery types behave differently as they charge and discharge, and those patterns show up clearly in the voltage profile. It's one of the easiest ways for engineers to identify what kind of chemistry is inside a cell. So when analysts studied the voltage curve from the Donut Lab test, the pattern looked extremely familiar. In fact, several engineers pointed out that the curve closely matches what you'd expect from standard Li-NMC cells. Li-NMC, short for lithium nickel manganese cobalt, is one of the most common lithium-ion battery chemistries used today. It powers everything from electric vehicles to consumer electronics. And while it's very capable, it's definitely not some revolutionary new discovery. That's where the questions start piling up. Because if the voltage signature of this supposed next-generation battery looks almost identical to conventional Li-NMC technology, then what exactly makes it revolutionary? Now, to be clear, this observation alone doesn't prove that the cell is Li-NMC. Voltage curves can sometimes resemble each other under certain conditions, but the similarity is strong enough that engineers expected some kind of explanation from Donut Lab. So far, that explanation hasn't come. No detailed chemistry breakdown, no technical clarification, no clear statement about what makes this battery fundamentally different from the lithium-ion cells already powering millions of vehicles around the world. And in the world of battery engineering, silence like that tends to raise eyebrows. If the charging curve behaves like a conventional lithium-ion cell, and the thermal behavior looks like a conventional lithium-ion cell, then the natural question engineers start asking is simple. Are we actually looking at a revolutionary battery technology, or are we just looking at a very aggressively marketed lithium-ion cell? It's a question the industry is starting to ask more loudly, and until Donut Lab provides a deeper technical explanation, that question isn't going away anytime soon. Section 5. The Control the Narrative Strategy. Now here's the part that raises even more eyebrows. Because this entire rollout, it wasn't accidental. Marco from Donut Lab openly said they want to control the narrative. And if you look at how the information has been released, that's exactly what's happening. Instead of publishing a full technical paper with all the data, which is what battery companies usually do when they're confident in a breakthrough, Donut Lab has been dropping one claim at a time, week after week. First, the fast charging numbers, then another small piece of data, then another teaser. Each reveal is carefully timed to generate headlines and excitement. But notice something important. They started with the easiest claim to prove. Fast charging. That's exactly what the VTT test confirms. But the biggest claims, the ones that would actually change the EV industry, are still missing real evidence. The 400 watt-hours per kilogram energy density, the 100,000 cycle lifespan, the extreme temperature performance, and the under $130 per kilowatt-hour cost. None of those appear in the report. So when a company says they want to control the narrative, and the data arrives piece by piece instead of all at once, it makes you wonder, are we watching a revolutionary battery reveal or a carefully managed hype campaign? Because if this technology is truly as groundbreaking as claimed, there should be nothing to hide. All right, let's be clear. The VTT report is real science. It comes from a respected Finnish research institution, and the data on fast charging isn't fake. That 0 to 80% in 4.5 minutes? Impressive, no question. But here's the thing. Fast charging is just one piece of the puzzle. Donut Lab's headline claims don't stop there. They promised 400 watt-hours per kilogram energy density, 100,000 cycles, extreme temperature performance, and under $130 per kilowatt-hour costs. That's 4 giant industry-changing claims, and the VTT report doesn't touch any of them. 1 out of 5. That's not proof. That's a start. Think about it like this. If someone told you they could run a marathon in 15 minutes, and all you saw was them jog a single lap around the block, would you be convinced? That's exactly what's happening here. The lab verified a single cell under controlled conditions, not a full battery pack, not a real-world motorcycle, not the full combination of crazy claims. So yes, credit where it's due, they can charge a cell fast. But one verified metric doesn't equal a miracle battery. Scaling this to real-world use is a whole other story. Heat management, pack-level integration, cost, longevity, all untested. The pattern here is what matters. Controlled releases, selective evidence, and hype around extraordinary claims. It's not fraud, yet. But healthy skepticism is absolutely warranted. If you want to see me break down the VTT test in detail and show why it actually proves almost nothing, including why those crazy claims on energy density and 100,000 cycles are still completely unverified, subscribe now and turn on notifications. The next video in this series is coming soon, and you won't want to miss it.